I don't understand why my sneakers don't like my chopper. What's up? I'll start with a little backstory, but closer to the middle of the video, I'll show you everything. Back when I was a kid, when I rode my father's Nepper, I was wondering, what is it like to ride with a motorcycle that you've completely gone through everything in it with your own hands? You rebuilt the engine, rebuilt the transmission, rebuilt the final gear, rebuilt the entire suspension, and you ride with this motorcycle. And the first bike that I've completely gone through everything in was my father's Nepper. And I'll tell you that after I completely gone through and I had a feeling like I feel every single bolt in this motorcycle, because I touched it in one way or another and I went through everything in this bike with my own hands. And I'm so confident about this bike. It's so reliable. I rode it for long runs and it handles anything without any problems at all. And that's such a cool feeling when you take a pretty much wasted bike, completely go through the entire motorcycle with your own hands, and now it's on the road again. It's mesmerizing. But in 2009 I got access to internet, so I started surfing forums, social medias, looking at custom cars, motorcycles, and I started wondering, what is it like to ride with a motorcycle that you've built by yourself? I mean, you built the frame, laced up the wheels, put your hands on a bunch of other little things, and in the end you go for a ride with this bike. So I built this thing, and you saw my face in that first ride video. I was just ecstatic. For me personally, there's probably nothing better than going for a ride with something I've built myself. So after I went for a ride with this thing, I began wondering what it would be like to go for a ride with something I've built entirely by myself. Literally from scratch, and I mean to build the engine and a gearbox too. I mean, yeah, I assembled this motorcycle myself, built the frame, built the front end, laced up the wheels, went through the engine and transmission, but the engine and training are factory made. I'm not saying that I want to build a bike 100% from scratch, like I'm not gonna make sheet metal, roll pipes, and cast rubber. There will be some factory made parts, but I want to make the engine, transmission, frame, front end, wheels, and everything else myself, and after that to feel what is it like to go for a ride with a motorcycle that I've built entirely with my hands. But the thing is, I'm a hick. I'll make everything as always in my hick manner, with a grinder, a hammer, a chisel, and tons of curse words. Maybe videos won't be coming out very often, but there are two reasons for this. First, I'm doing everything by myself and it takes a lot of time. Work in a garage, shoot the video, edit the video, etc. Second, I never tinker with bikes so I can make a video. No, I build and fix bikes because it's my passion, literally the meaning of my life. And videos are like consequences, something that I do along the way for older myself to check out what I was doing when I was young. Due to the fact that I don't have access to milling and CNC machines, I'll be making everything for quite a long time, but I will finish it one way or another, it will fire up, and we will go for a ride. I know that it won't be easy as pie, like that's it, I built it, started it, it works, and everything's set. I suppose there will be breakdowns, rod knocks, and all sorts of other mess, but I'm such a stubborn donkey that I will finish it and it will start and drive. Now let's jump to the garage and I'll show you everything. So we're in my garage and I'll warn you, if you have a weak psyche or rather unstable nerves, then I advise you to better close your ears or better yet your eyes and better not to look at all, because now it's gonna be a crap load of yokel science. What the heck is this? Nah, it ain't my tool. There's no point for it to be around here. Okay, so I'm presenting the beginning of the work on my homemade V-twin engine. So a 2-cylinder V-twin engine with a linear cylinders arrangement, which means that the cylinders have no offset to the sides. The camber between the cylinders is 45 degrees and the piston stroke is 86 millimeters. The case will be made of steel because I currently have no opportunity to aluminum cast it. Plus I don't have a milling machine to process everything correctly, and I simply don't have a TIG welder, so if necessary to weld something. Also, there will be parts in this engine that I kind of have doubts about their strength, so if something inside shatters, then at least the case, which is made of steel, will definitely survive. Since I love KMZ Dnippers so much, I decided to use a Dnipper top end, but nevertheless, the pistons, heads, and cylinders will be modified one way or another. And also because the top end is like the easiest thing to make, unlike the bottom end. At the moment I have the cylinder base ready, the crankshaft is almost done, and connecting rods and their pin are completely finished. The linear arrangement of the cylinders is possible because of this fork type connecting rod, so that's the rear rod, this is the front one. The front connecting rod is inserted into the rear layer 1, and all of this as an assembly will work together. It'll be dry sump lubrication system, which means I'll install 2 oil pumps which will work simultaneously. The first oil pump will pump the oil into the engine, the oil will flow through the entire engine, go down to the bottom of the engine block, and then the second pump will pump the oil out of the engine and send it back to the oil tank. The distribution system will be similar to old flathead or Sportster Harleys, which means 4 one-lobe type camshafts. But actually there's no point of thoroughly describing what this engine will be like because you'll see everything in the nearest future. Let me show you where I started and what I've done so far. I started by making this hydraulic press. I made it from what was lying around the garage. It's got a 5-ton jack, and despite the fact that the frame is quite thin, I was able to easily unpress several KMZ K750 crankshafts with it. So I built the press. With this press I disassembled 2 K750 crankshafts, from which I pulled out 4 connecting rods. Also I disassembled a crankshaft out of a PD10. Next is a night move. Take a hammer and hit the leaf spring. That's it. It moved. Magic, you say? No, a hammer, I say. Seems like that the most important tool here is not the press, but this friend over here. PD10 is a single-cylinder gasoline starter engine out of a diesel tractor. With a piston stroke of 86mm, the displacement with a nipper top end increases from 650cc to 820cc. Next, I took a gas 52 axle shaft in order to machine a crankshaft rod pin out of it. The gas 52 axle shaft is made of structural alloy steel, sort of like 1039, which is not entirely suitable for making a crankshaft pin out of it. Of course, it would be better to use bearing steel like 52100, but unfortunately, it's almost impossible to heat treat it correctly at home, but with 1039, we can still make experiments. So I annealed a piece of gas 52 axle shaft, machined the pin out of it, then I carbonized it. I made a carbonization using coal and graphite in a closed barrel, so-called coffin. I think you can hear it by the sound. It feels like I'm trying to file a lathe cutter. Dang it, I murdered the file. After carbonizing, I hardened this pin and then baked it in the oven at 250 degrees Celsius to abatement it, and it turned out to be this sort of carbonized pin. To be honest, I don't know how long it'll last. The file cannot do anything to it, I hope it's hard. Next, I took a piece of a thick 5/8 of an inch plate, sandwiched the both pieces together, tacked them, and took them to a local machinist. He made holes for the cylinder, sent for the studs, cut the threads, and also drilled holes for the drain tubes. Next was the hardest part, setting up these plates. I'd fiddled with 2 levels for a very long time, but in the end it seemed like I managed to align both plates properly, one in relation to the other. And at the very end, I hope I won't be lazy to take it all to a machinist so he mills down all these surfaces. After setting up the plates, I welded them. When the crank pin was ready, I could begin making the con rods. The con rods are made out of 4 K750 rods. Here's one connecting rod, here's the second rod, that's the third, and the fourth rod is an ordinary connecting rod, which I just narrowed the big rod end sides. I set both 3 rods BREs by pressing a caprolon mandrel into them. After that, I tacked them, pressed out the mandrel, and welded them. It ain't no good anyway, so don't you worry. I welded the rod with stainless electrode. The difficulty was that I needed to heat the metal sufficiently so the welding can penetrate it but not spoil the cementation layer. Therefore, to cool the cemented part, I simply shoved a wet rag in here and it coped with its task with a bang. Then it took me a very long time to adjust everything weight-wise, because in this case it's very important for the weights of the both SREs to be the same. BREs are placed on the same crank pin and it's a matter of balancing the crankshaft. Both SREs should weigh the same and I ensure their weights are the same by lightening the SRE of the rear rod. As a result, after all the grinding and welding abuse this poor connecting rod took, it easily passed a hellish test in my 5-ton press. So I'm 100% confident that this con rod is reliable. As a result, we have 3 sets of roller bearings from a K750 engine. In the end, all this goodness will live on one crank pin. From the beginning, I wanted to make a crankshaft with liners. But the problem is, for example, a Dnepr connecting rod, which works on liners, weighs 200 grams more than a roller connecting rod. But roller bearings on a crankshaft have one big advantage over liners. Rollers don't need forced lubrication. I mean, liners, to work normally, require pretty high oil pressure. And now let's take a K750 lubrication system for an instance, where the oil goes along such a washer and simply enters the pin due to centrifugal force. A K750 has 8 psi of oil pressure at high revs, but nevertheless this is more than enough for the rollers to stay lubricated. And actually, on the contrary, it's pretty bad for rollers to experience high oil pressure. Rollers stop spinning and start sliding. Next, and it was a whole epic for me, the crankshaft. I lightened the PD10 crankshaft up top as best I could. I cut out these windows, here was a solid line, I ground it off, and this half I even cut off these ears here, and it still didn't come even near to any balance. In order to balance such a crankshaft, you need to hang one complete set. The rear connecting rod with a piston, with a wrist pin, with rings, with 2 sets of bearings, plus the weight of the BRE with bearings of the front connecting rod, and all this must be balanced. And of course, the weight of the counterweight of this crankshaft, on which resided one little PD10 piston with its rod, was not enough. And for this, attention, hick activity, I had to weld to the counterweights of each flywheel a piece of, what you think? Right, leaf spring. And during the preliminary balancing with welded pieces of leaf springs and all the additional weight that needed to be hung on this pin, it turned out that I hit the weight that was really close. So just by welding on a piece of random thick leaf spring, it turned out that I got it right on the money. Man. Yokel balancing in yokel conditions. For balancing, I used my second very similar pin. It has the same exact weight as this pin, but because it's slightly smaller in size here, it easily fits into the flywheels. All this so I don't have to press the main pin in and out many times. The pistons I took from a Dnepr 1036 simply because I had 2 pistons with broken skirts. I cut them flush where the oil ring land begins, and yes, I know it should have a skirt here, even a small one, but it should have it. I won't have it because, well, I'm a hack and it's gonna work just fine for me. But actually, it's not that easy and simple with the pistons. I'll explain you why. Here we have a Dnepr cylinder and piston. In a Dnepr engine, the piston moves like this. The valve recesses are located here. But here my cylinder is placed like so, and the piston should be rotated 90 degrees because, accordingly, the connecting rods are placed like this. From that follows that the valve recesses now must be rotated 90 degrees. I can't TIG weld the old ones, so I'll just cut new valve recesses here. So I think I briefly described you what I have at the moment. The next step was to make bearing seats and having the seats assemble the crankshaft, and then make the engine case around the assembled crankshaft. But in order to machine seats for a 206 bearing, I needed an 80mm steel bar. Obviously I didn't have one, but I did have a very thick square plate, from which I cut off 3 pieces, and I wanted to machine 2 bearing seats and 1 oil seal seat. But it turned out that this plate was a little hardened and quite difficult to machine, so now I need to anneal it and give it to the turner again. When the bearing seats are ready, I'll be able to assemble the crankshaft, make the final balancing, and build the case around the crankshaft. After the case is ready, it'll be possible to make the timing system, lubrication system, and so on. I foresee a number of questions like, dude, what are you even doing? You really want to make an entire internal combustion engine in your garage with only a welder, angle grinder, and a hammer? Yeah, I understand. Once I thought the exact same way about the fork and the frame, but everything worked out great and the bike rides perfectly fine. Same thing here. But if you have any doubts that it will work, just please read the story of Burt Munro. If you don't know his story, just please get acquainted with it. So basically, that's all I wanted to show you in this video. Catch you next time.